Hello everyone. On this part we have quantity data. The first step in summarizing quantity data is to determine whether the data are discrete or continuous. And if the data are discrete and there are relatively few different values of variable, the categories of data or classes will be the observations. And so that was for when our data are discrete. And if the data are discrete but there are many different values of the variables, or if the data are continuous, the categories of data or classes must be created using intervals. So when we have continuous, we're gonna use intervals of numbers. We're gonna work on these to see what the difference is while working on examples. Okay, organize discrete data in tables. We use the values of discrete variable to create the classes when the number of discrete data values is small. So when the data value is small, we're going to use this part. So this part is example for discrete data. The following data represent the number of variable cars in the household based on random sample of 50 households. Construct a frequency and relative frequency distribution. Okay, so we have all this data and we already have this information for frequency and relative frequency. The first column is number of cars. Here we have 0. See how many zeros we have here in this table. We have 1, 2, 3, and 4. So we have 4 in total. The second column we used tally, and third one for frequency. So how many times we have that 0 here in this table is 4 times. The next one, number of cars is 1. 1, 2, 3, 4, 5, 6, 7, 9. And so in total we have 13. Exactly same as what we did for the first part. Using tally and second row, we have 13 here. And running the number as 13. So do same thing for all these numbers on the first column. We have 2 cars, 3 cars, 4 cars, and 5 cars. I have these numbers based on what we have here in this table. Here in this table, the numbers that we have are starting from 0 up to 5. So 0, 1, 2, 3, 4, 5. So how many 2 we have here? We have 22. 3s are 7 here, and 4 we have 3 4s here, and 5 we only have 1. That's this one. Okay, then after that, since we want to find relative frequency, we already have the information here, and you can see that each one should divide by sum of frequency. So for frequency divided by, okay, I'm writing it there. It's frequency divided by sum of frequencies. This is relative frequency. Okay, so since here denominator is 50, that means that we have 50 on this board. So if we add these numbers, total is 50. We covered this one in the previous section. So each one divided by 50 is the answer for relative frequency. Now let's see what's the question here. What percentage of the households had 2 cars available? So the part that we want to work on is 2 cars, and that is this part. And what is the answer for relative frequency is 44%, since it's asking for what percentage of household instead of using this decimal point, using percentage. So it's 44% for 2 cars. The next part, what percentage of the households had more than 2 cars available? So it's more than 2 cars, and that is this part. So adding all these we have here, and again use percent. You have 14, 6%, and 2%. So adding all these is 22%. So that is the final answer for this part. Okay, now next page, construct histogram of discrete data. Okay, this is a histogram we have. What that is constructed by drawing rectangles. So we have rectangles, and that is for each class of data. The height of each rectangle is frequency or relative frequency, so it depends on what asking us. If it's asking us to construct a frequency, the height is based on what the frequency is. If it's asking for relative frequency, our height is based on the numbers that we have for relative frequency. So we have height, frequency, or relative frequency of the class. Then the width of each rectangle is same, and the rectangles touch each other. So based on what we have here on top, let's work on this part. Example number 2, construct the frequency histogram and the relative frequency histogram. So we have these two. First frequency, and the other one should be based on relative frequency. And that is based on the data in table from example number 1 that we had here on example number 1. So based on these data, we're going to construct a histogram of so based on a frequency and relative frequency. Let's have frequency first here on the first one. Okay, so here I'm writing that this is what we have for number of cars. So this is for available cars in the household. The numbers that we had for frequency, here we had 1, and the largest one was 22. So let's start 0 up to 3. So here is 0, 5, and on this part we have number of cars. So x-axis is number of cars. And here is frequency. Number of cars, we had 0, 1, 2, 3, 4, 5 cars. Okay, so here for 0 cars, frequency was 4. So that is 4. I want to keep these numbers in center of these rectangles. For 1, we had 13. Okay, I want to use different colors so you can see. So these are rectangles. And for 2 cars, we have 22. Okay, I'm writing what we had here, what the frequency was. That was 22. Here it is 4, and this one is 13. Then 3 cars, the frequency is 7. And 4 cars, 3. And 5 cars is 1. So I want to keep these numbers in center of each rectangle. So this was for a frequency. Now the other one is for a relative frequency. And based on what we have here is this is 8%, so we have all these numbers. I'm going to start from 0 again. Okay, so here is 0, then here is 0.1, 0.2, so 10%, 20%. Here 40%, 50%, and 60%. Again, number of cars, 0, 1, 2, 3, 4, 5. And y-axis is relative frequency. Okay, I use same colors that I had here on this part. We should have exactly same shape. So for the first one, we have 8% is here. For one card, 26%. That is 25. Here is 26. Next one, 44%. Three cars, we have 14%. And for four cars, it is 6%. And five cars is 2%. Again, I'm keeping these numbers 0, 1, 2, 3, 4, 5 in the center of each rectangle. As you can see, it doesn't matter which one we use, either frequency or relative frequency, we have exactly same shape. Next page, we want to organize continuous data in tables. So instead of having discrete data, now we have continuous. When we have continuous data, we're going to use intervals because we don't know what how many numbers exactly we have. That's why we're going to use intervals. So here, use intervals of number span. Then we have, okay, when our data set consists of large number of different discrete data values. So that is the first one. Or when a data set consists of continuous data. So these two are same, having a large number of the different discrete data value, or when a data set consists of continuous data. Then, we should use, okay, so this is the, so we have these two. And for this kind of data, we should use intervals. Let's see what we have here. The following table is based on frequency distribution created from continuous data. So that is using continuous data. The data represent the number of the US residents ages 25 to 74. So here we have 25, starting with 25 up to 74, who have earned a bachelor's degree or higher. Okay, so what we have here, we have two columns, the first column and second column. The first column that we have, these data 25, 35, 45, 55, 65, these are lower limit. And what we have here on this column, the second column, 34, 44, 54, 64, and 74, these are upper limit. So these are upper. Okay, so each one of these are interval, and each interval represents a class. So this is our interval based on continuous data, and that is our first class. So here we have 5 classes. We have 1, 2, 3, 4, 5 classes. The first class is 25 to 34-year-old. That is not exactly equal to 34. This is 34.9999, and it's very close to 35. That's why after that, here we have 35. Okay, so here we have 5 classes, each with a lower class limit. So as I said, on the first column we have lower limit, so that is lower class limit, which is the smallest value within the class. So the smallest value that we have here in the first class is 25. Then after that we have 25 point something, or 26, we can say 27, depending on what is the width of your class. We're gonna cover that later. And so the lower class limit for the first class is 25. Here is 25, and the upper class limit is 34. The class width is the difference between what we have here is this part important. The class width is the difference between consecutive lower class limits. So using this table, finding and class width, you should subtract 35 minus 25 is equal to 10. You're not able to subtract 34 minus 25. You're gonna get 9, and that is wrong, because here this is not exactly equal to 34. This is actually 34.9999. We have that part here. And if you subtract these two numbers and round it, the answer for class width is again equal to 10. So class width is not equal to 9. So this is wrong, and that is equal to 10. So this is what we have. So this means that we have continuous data. We may have 34.90, 34.91, 92, 99, and so on. Okay, so for all of these, it doesn't matter which one you choose, class width is always equal to 10. So starting from that part, we used 35 minus 25. This was class width, which was equal to 10. Now what if you tried 45 and 35, these two classes? Again, we have 10. So 45, you should use consecutive classes. Is the difference between consecutive lower class limits. You're not able to subtract 65 minus 45. That is wrong. So consecutive lower class limits. Now I have 45 minus 35, again 10, and 55 minus 45. For all of these, we should have same answer. The last one, 65 minus 55. Here again is 10. So we have same results. Regardless of what classes you choose. But the point is, those should be consecutive. Okay, next page. Example number 3. The following data represent the time between eruptions, that is in seconds. For a random sample of, we have 45 eruptions. We should construct a frequency and relative frequency distribution of the data. So this is what we have here on this table. And here on this part we have time between eruptions. These classes are based on the data that we have here. Here I want to find what the maximum data value and what the minimum value is. This is minimum number that we have here in this table. And here is max. Okay, the point is that when you wanna construct all these classes, lower class limit of the first class and the class width are arbitrary. So what that means, you can choose different class width to have different so to have different classes here. For example, here I have the class width is 10, so we have 7 classes in total. And here, as you can see, the difference between these two numbers is 5. So class width is 5, that's why we have the total number of classes that we have is more than we got here on the first part with class width equal to 10. Okay, lower class limit. Of the first class and also the class width are arbitrary. What that means, there is not one correct frequency distribution. We may have many. So there is not one correct okay. Frequency distribution. Okay, let's see what we have here. We already have these numbers, and the first lower limit that we have is 670. But here minimum value is 672. The point is that I want to have all these numbers that I have, keep these numbers in the intervals that we have for each class, meaning that I shouldn't start from 673 because I want to have that number here in this interval. We can start from 670 and have this number here in that interval, so that is correct. And what we choose is what that first class limit is, lower limit is, and also what we want to have for class width. We decided to have class width equal to 10. That's why the first one here on the first column we have is 670, then after that is 680, 690, 700. So adding 10 to each one to build what we have on the first column for lower limit of each class. But here is class width of 10. And on this part we have tally how many numbers we have in that in this interval. Here is 672. Then we should have another one between these numbers. Okay, here is 678. Yeah, so we have two numbers, 678 and 672 in this interval. That's why we have this for tally. And between 680 and 689, we have nothing here in this table. Between 690 and 699, we have 7 numbers. Okay, I'm writing these here for frequency, so it's 2 0 based on these tally. This column, I'm counting how many I have. I'm writing the answer for that part. So this is 9, 11, 7. And sum of frequency is equal to 45. So this is sum. Now here, find a related frequency dividing each one divided by sum. So sum is 45. Rounding that. Here I have 0.044. So this one obviously is equal to 0. And here I got, I'm rounding all these, and here I got 0.1556, 0.2 or 0.20. Here again 0.2, 0.2444, again same as that one we have 1556. And if you try to add all these numbers, should be equal to 1. So that is 1. So adding those numbers should be equal to 1 or very close to 1. Okay. So on this part here we had class width was 10 and number of classes we had 7. With here class width we divided that number that we had, so 10 divided by 2. Now class width here we have 5. It's not like, okay, I divided that. I'm just choosing what class width I want to have here. So class width here is 5, and number of classes. So here 10 divided by 2, we have 5. Now number of classes is, here we had 7. So 7 multiplied by 2, now we have 14 number of classes. So you can say that we have that formula for this part. When you're dividing class width by a number, you're going to use exactly that number multiplying by number of classes to have the number that you have here. So what is that one is? From this part, class width was 10. So that was divided by 2, and we got 5. Since I divided by 2, now from here, number of classes are 1, 2, 3, 4, 5, 6, 7. So 7 multiplied by exactly same number that we divided here, so multiplied by that number here is 14. Number of classes. Next page, procedure for constructing frequency distribution. Okay, we construct frequency distribution so that large data sets can be summarized. We want to summarize our data. That's why we're constructing frequency distribution. So this is one reason for that. The other one, we can analyze the nature of data. And also we have a basis for constructing graphs, such as histograms, introduced in the next section. Okay, we already had this one here, so okay, disregard that one. Also, we can use technology. So here are our steps. So these steps for constructing are as follow here. The first one, determine the number of classes. Exactly what we did on the previous example. How many classes we want. So on the first part, we decided to have 7 classes. So these are number of classes, and also what the class width is. So the number of classes should be between 5 and 20, and the number you select might be affected by the convenience of using round numbers. Okay, then calculate the class width. Okay, here we have typo. Okay. Okay, on top we have maximum data value minus minimum data value divided by number of classes. Oh, it's here, huh? Okay, number of classes. Okay, so this is how we can find a class width. Let's find this one based on the previous example. So what we have here is that step 3, run this result to get convenient number. We usually run that up. Maximum data value here was 738 and minimum was 672. So use those 2 numbers. Minus 672 divided by number of classes is 7. So here is 9.4. I don't want to have this one numbered, so round this up is 10. So this is our class width. So here we got exactly the same number that we had here on the first part. Class width was 10. Here, step 4, choose either the minimum data value or a convenient value below the minimum data value as a first lower class limit. Okay, so once again, I explained that how we're going to choose that number. Either choose the 672 or a number that is smaller than that. You can choose 671, 672, 669, or this one we have 670. Okay, number 5, using the first lower class limit and the class width. Then we're gonna use these two, and then adding class width here. So we have this one, 670, and we know how many classes we're gonna have is 7, and we decided on what class width is. Then building these classes are easy. You only need to add class width to that one. So 670 plus 10 is 680, 680 plus 10, 690, and so on, up to here 720 plus 10 is 730. Then after that, you should see what is the maximum value. Data value here is 738. Okay, and here we have 729. Again, I can say, okay, for that part again, I did the same thing. Plus 10, we got 739. And we stop here because we already have all these numbers in these intervals. And also, we already have 7 classes. So that is what I explained here, these 2 steps. Okay, and then after that, we got these numbers for frequency. So that was step 6. Okay, next part, construct histograms of continuous data. Construct a frequency and relative frequency histogram of the eruption times in example number 3. So this is example number 3. We're going to draw these. So here on this part, we use intervals because our data are continuous, not discrete. So here on this part, we are using intervals. Here on this part, and that is because our data are continuous. And not discrete. So here we should label our x-axis with lower class limits. Okay. So here is an option of what was that one? Option of Old Faithful. I'm writing that here. So what's here? What is that? Okay, your option, add Old Faithful. So I wrote that part. Okay, so this will wanna have relative frequency and here for frequency. The same thing here, we have our option. And the data that we have for this part are, okay, again, starting from 0. Here is 5%, 10%, 15, 20, 25. So this one is for relative frequency. So I'm not writing that here. Okay, let's write it. So this is for relative frequency. And here is frequency. And here, this column was time between the options. So here is 0, 2, 4, 6, 8, 10, 12. Okay, now writing our classes here. As you can see, that is 0, so I'm not starting from that part because our classes start from 670. Lower class is starting at 670. So I'm gonna write all these classes. And what I use, the numbers that I use are 670 up to 680. I'm not using that one because this is 679.9999 is like that. I'm not able to write that way. So I'm using these lower limits. So 670, 680. So do the same thing exactly for relative frequency on this board. You may say, okay, the distance here is 10, but here I should have 669 numbers before that. Why we have the same difference? So that's fine, because we don't have, we're not able to write that number here, for example. So that's fine. We can write this way. Doesn't matter. So 680, 690. Same numbers. Oops. Okay, so we have all these lower limits, and this one is not lower limit. This is upper limit. because the lower limit was, here we had 730, then after that we have 739.9999, which is equal to, approximately equal to 740. That's why here in the final part we have 740. Okay, so between 670 and 680 we have two numbers. Between 690, 700, okay, between 680, 690 we have nothing. Then between 690 and 700 we have 7. So frequency for this part was 7. See, here we have 7. So that is 0, here is 7. Okay, I'm trying to draw a rectangle for each part. Next one is between 700 and 710 we have 9. Again 9. Here is 11. And this one's 7. So this was for frequency, and here on this part is for relative frequency. Okay, so this is 5%, and here we have 0.044, very close to 4%. And then here is 0.1556. So that is 0.15 or 15%. %20%. Again 20%. Next one, 0.2444. And finally, point 1556. Okay, comparing these two, you can see we have exactly the same shape. Okay, now next page, we're gonna draw a stem and leaf plots. Stem and leaf plot uses digits to the left of rightmost digit, to form the stem. So that is for stem, and each rightmost digit forms leaf. So, for example, data value of 147, we have 14. This one is as a stem and 7 as a leaf. Because our stems are the digits to the left of rightmost digit. This one, 7. The 7 is rightmost digit. And here we have what we have on left. These are the digits that we have on the left of this rightmost digit. So these are on left. Example. We have these data in this table. And that is for the years 2008 to 2009. You should draw stem and leaf plot of these data. So, okay, I'm drawing that for here. So the digits to the left of rightmost digit are stem. I'm writing that part because these numbers are on left. I'm writing these on left column. And here is what we have for rightmost digits. Okay, for example here, Obama we have 15.4. That 15 is here on the left column is for stem. 9.9, 9 is here. 19.6, 19 is here. 17.1, 17 is here. So I'm writing all these numbers here in order. So rightmost. Okay, let's write that for here because this is not for this example. So rightmost digit is the 10th place. So these are left, and for stem, those numbers that we have to the left of rightmost digits. So for example, The first one we have Alabama. The stem is 15 and leaf will be 7. Okay, so I'm going to write all these numbers in order. We have 7, 8, 9, 10, 11, 12. 13, 14, 15, 16, 17, 18, 19, 20. So we have all these numbers here in this table. Oops. Okay. Okay, now writing what we have here on right. So this one is 7. We should find how many 7 we have here. 7. Okay, here is 1. So that's the only one we have. And rightmost digit is 4. Then we have 8. 8. We have 8.2. And 8.6, so we have 2. Now writing the rightmost digits as 2, and here is 6. Now we have 9. 9.1, 9.3, 9.2, and 9.7. So here we have 5. We'll continue this way, finding all these numbers and writing numbers here. So we have 9, here is 1, 3, 2, 7. We usually should write these numbers in order, in ascending order, but even if you didn't, that's fine. But later you should rearrange all these. So first I'm writing that way to show that we have to arrange them again. Now for 10 we have 10.9, 10.1, 10.5, 10.2, again 10.5, 10.3. You can repeat. So we have to write all those numbers even if the number repeats. Be careful of when you writing these numbers, because if you miss one of these, the answer will be wrong. How you can say that what you got here are correct? You only need to count how many numbers you have in total here and how many numbers you have here in this table. If you got same thing, that means that you didn't miss any number. Okay, so we have 13.6. Here is 14.4, 15.4, 15.0, 0.2, again 0.0, 0.4, 0.8, and 15.2. 16.9, 17.1, 20, 18, we have nothing here, 19.6. See, even if we didn't have that 18 here, but since I had all these numbers in order, that's why I had 18 here as a stem. Okay, then a 19.6, 19.3. Here is 20.6. Okay, so we got all these numbers. Now we want to arrange these. So arrange leaves in order. Again, rewriting this column. Okay, and this part, so we have 4, 2, 6, and we have 1, 2, 3, 7, 9. So these are in ascending order. For 10, we have 1, 2, 3, 5, 5, 9. Here is 0, 0, 1, 2, 4, 7, 7, 9. 12, 0, 8, 9. 0, 2, 2. 3, 5, 5. 6, 9, 9. Here is 4. For 15, we have 0, 0, 2, 2, 4, 4, 8. 2, 6, 9. 0, 1, 2. For 18, nothing. Here is 3, 6, and here is 6. And also, here between these numbers we have nothing. Some students make mistake using a comma in between. So that is wrong. You shouldn't use anything in between. Here we again we have steps for this part. So step 1, stem of the data of a data value will consist of the digit to the left of the rightmost digit that I explained here, and leaf is the rightmost digit. Step 2, write the stems in the vertical column. So we had these in vertical column, that is in increasing order. So these are in increasing order. And then draw this vertical line to the right of the stems. This one. Step 3, write each leaf corresponding to the stems to the right of the vertical line. So we did that part. Step 4, within each stem, rearrange the leaves in ascending order. So we arrange that in ascending order. Then title the plot and include the legend to indicate what the values represent. Okay. So titling that one. So that one is for 2-year average percentage of persons living in poverty. So I'm gonna write that one here. What the title is. So we have exactly what we have for this part. So exactly same title. And also, okay, what include legend? We're gonna have that here on this board. So let's have example. For this, I can have so here we have 7, 4. So that represents not usually will not usually ask you what the legend or what the title is. You only need to focus on how to construct these, write these numbers, so stem and leaves, and also arranging them. So this is 7.4. So here is what the stem is, and here is what leaf is, and that representing this number is 7.4, which is here on this table. We finished that one. Next page. Here again we have a stem and leaves. What we have here is split stems, and that is when we have too many numbers in one class. So these are the data we have. Based on these data, on the first column we have stem. So we have these stems here, and here are leaves. And then we want to split these stems to have this part instead. what I have on the first row, we have for STEM we have 1. Now dividing by 2, we have 1, 1, so we have 2 classes. So how we can decide how many numbers on top and how many numbers here on the second part? What that is, this one is classes starting from 10 to 14. That is actually 14.999. It's like that. Then here is 15 to 19. What is that 10? What is that 15? See, these numbers on the left side are our stems. So that is 1. Here is 1. The numbers that we have here are in this interval. So we have 11, 11, 12, 13, again 13. So these numbers are here. Then we have 15, 15, 16, 17, 17, 17, 18. So we have 4, 18, and then 19, 19. All these numbers are in this interval. So our class lower limit starting with 15, and we have exactly same number on this part. Okay, the next one is, here is 2, and we have 2. And after 19.9999, we have 20, up to 24. So yeah, I have 24 here. 2 and 4, we have 24. What is that one is? 25 up to 29. This is 30 up to 34. That is 35 up to 39. And oops. What is that one is? 40 up to 44. We have nothing in that class. And this one is 45 up to 49. See, we have 46, 48. These two numbers are in this interval. So, and this is how we decide what numbers belongs to which part. So instead of that one, now we have this part. Okay, here is an advantage of using Stanley diagrams or histograms. So once a frequency distribution or histogram of continuous data is, so continuous data is created, zero data is lost unless reported with the frequency distribution. However, the raw data can be retrieved from the stem and leaf plot. So that is the advantage of using stem and leaf diagrams over histograms. So we finished that part related for stem and leaf. So for this part, you can see all data that you have here. That's why it's more clear to use as method of histograms. That is the advantage that we have over histograms. The next part, draw dot plots. This part's easy. You only need to see what numbers you have here in each table. Here we have, this one is example number 1, yeah. So this is example number 1, sample of 50 households. Again, we have number of cars. The dot plot is drawn by placing each observation horizontally. We're going to use horizontal line and use dots. And that is in increasing order. Plot, okay. Placing a dot over Let's okay here. First, these are number of classes. We have 0, 1, 2, 3, 4, 5, and we're gonna place a dot about the observation. Each time it is observed. So for 0 cars, we had how many cars we had was 4. That's why we have 4 dots here above that 0 cars. And then for 1 cars, how many cars we had? 1 cars was 13, so we have 13 dots here. This one was 22. Here we have 7 dots. For 4 cars we have 3 dots. 1, 2, 3. And here for 5 cars we have 1. So frequency was 1. That's why we have 1 dot above that port, that number. Okay, so I'm gonna add this part that we can use dot plots for either discrete or continuous data. Okay, next part. Here we should identify the shape of distribution. Here we have all these 4. So the first one, uniform distribution, bell-shaped distribution, skewed right and skewed left. For uniform distribution, we have same frequency, exactly same number for frequency. The frequency of each value of variable is evenly spread out across the values of the variable. So here we have exactly same number for frequency. The next one, bell-shaped. So this was uniform bell-shaped distribution. The highest frequency is in the middle. So this one is the highest frequency that we have. That is bell-shaped. Next one is skewed right. Is this one here. So the tail to the right of the peak. So this one is here is peak. Because that is the highest point we have here, highest frequency. So the tail to the right, which is this one. So the tail to the right of peak is longer than the tail to the left of peak. So this part is longer. It is longer than what we have here on this part. See, that is longer. And same thing here. Again, this is the highest frequency we have. And here is skewed left. The tail to the left is longer than what we have to the right. This part is longer than what we have here. Example, the following frequency histogram represent the IQ scores of random sample of 7th grade students. And those are measured to the nearest whole number. The frequency of each class is labeled above each rectangle. So here we have these frequency are here for each rectangle. Part A, how many students were sampled? What that means, find sum of frequency. Find sum. These are frequencies that we have, so adding all these numbers to find total number of students. We have 2, 3, 13, 42, 58, adding all these. Plus 42, 58, 40, 31, 8, 2, 1. In total, we should have 10 because we have 10 classes here. That is equal to 200. So we have 200 students. Part B, determine the class width. Remember that said this one is the lower limit. So these are lower limit. 60, 70, 10, 80. So our class width is 10. 70 minus 60 is 10. So choose consecutive class. So consecutive classes, like you can choose 80 minus 50 or 90 minus 80. Doesn't matter which one you write here, but you should have same class width, which is 10. So here, subtract any two lower limits. Any two consecutive lower limits. Next part, identify the classes and their frequencies. Okay, let's draw that here. So this is for part C. Okay, so here is IQ scores and this part their frequency. This one is IQ and here frequency. We have 60. This is 70, but we shouldn't write 70. This one is 60 up to 69, which is 69.9999. So 70, 79. Ninety, 99, 100, 100, 109. One 110, 119, Okay, I have 2 more classes, so I'm writing that part here. Okay, we have 140, 149, 150, 159. And what is the frequency for each one here is 2, 3, 13, 42, 58, 40, 31, 8, 2, 1. So this is what we got for part C. And then part D, which class has the highest frequency? So which one has the highest frequency is this one in between. Obviously this one is bell-shaped because the highest one is, we can say that is in middle. So this is highest. And which, since it's asking which class, or classes 100 to 109, which is this one. This is highest. So that's the answer for this part. Part E, which class has the lowest frequency? Lowest frequency is this one here. That is 150, 159. Part F, what percent of students had an IQ of at least 130? Well, at least 130. So this is IQ, at least 130, so we have 130 or higher. And the frequency is, are these 3 classes. And the frequency 8 to 1. We have 8 plus 2 plus 1, asking for what percent of students to divide by total number of students was 200 from first part. So that is equal to 55%. Okay, so the answer for part F is 55%. H, describe the shape of distribution. As I said, since we have this highest frequency in between, this one is bell-shaped. Part G, did any students have an IQ score of 165? These classes are 150 up to, so the highest one that we have here is 159, because that is 160. And we stop here. We don't have 165. IQ score 165 is not here. So the answer is no. So we don't have IQ scores above 161. Okay, so that is 160. I'm going to use 159. Because here we have these classes. This was the answer for part G. Okay, we finished this part.